Yes, Ilkay, please.
Thanks, Amal. Great talk. So you have observability in performance, but you're including resilience and trustworthiness in your observability framework.
Yes.
How do you decide which one is a function of which?
Which one is a function of which?
Yeah.
Okay, so the first part was talking about characterization of workflows, and the last part is definitely part of the first one, because in the characterization of the workflow, we also included not only the telemetry, but also the provenance. And I guess the provenance is something that we cannot ignore nowadays. I mean, usually it's like a luxury, but nowadays I think it's a must in these agentic workflows to be able to understand what's going on in these workflows. And for the second one, which is the resilience, I guess, so it's a funny story. I've used my tools from the performance characterization to understand the resilience of some programs, and that's definitely the workflow I presented here. And it's so funny that sometimes it works, sometimes it doesn't. I was not able to understand what's going on until I went like very low level, and the problem was that some nodes in Polaris were misconfigured, literally. And there is no way from the tools I have used to see that these nodes are not configured. So mainly from my point of view, it's just some nodes crashing, and I'm not able to instantiate my RPC servers, and I'm not able to establish connection with them. So it's just failing. But at the end of the day, going down to the configuration of the system that we collected, again, from the configuration of the job and the nodes that we are used. So we got to that level, or where we could say that, oh, actually these tools, or these nodes are misconfigured, and they do not accept RPC connections. They are just configured to accept MPI connections. So that's the way, at least, I see the connection. I don't know if that answers your question.
It does. I think there are other questions, but may I ask one more?
One more.
Okay, great. Thank you. I can, of course, ask later. So I love the parallel coordinate chart. It kind of assumes there's an objective.
Okay.
Because you're sort of, at the end of it, there is a level that you're working back to the different parts of observations. So
I'm going back there.
if you were to do trade-offs between these, and first of all, is this retrospective, basically? Are you just seeing the phenomena, or is there loop back that you're changing scheduling decisions here?
So yes, so the point from these experiments actually was to understand the variability in distributed task systems. And you'd say, yeah, it's normal to see variability because they are dynamic. But then we want to understand further, okay, how does this dynamicity in the scheduling of the tasks impact the performance variability of the workflow in general? Is it like, will we see it at the level of the workflow or at the level of the tasks? So that was the goal from this experience. And then the second question was, what was it? Sorry.
And then when you understand, is there a way to go back to scheduling decisions?
Yeah, so yes. So what we understood from this was that these tasks were problematic. And I don't know if you can see it, but it's read, parquet, fused, assign. So it's like 3 tasks that I didn't create, by the way. So these are tasks created internally by Dask, because it's just a great tool, but sometimes it does this. So mainly, I was not aware about this fusion between these different tasks. So there is IOs, there are fusions, so there are communications between different tasks, and then there is an assignment of these different tasks to different workers. So mainly, by understanding that, I can actually tune better the parameters of my task graph so that these tasks become less big, mainly smaller, or like get closer to the recommended size by Dask. So mainly it's just me then taking action to improve the performance of the workflow. But yes.
Yes, Eric.
I think it's quite interesting that we can draw a parallel between workflow and task level observability with agent provenance tracking, because both operate in the transparency layer to increase the confidence as to what we're observing, right? However, it strikes me that when we think about workload observability, a lot of the data that you're collecting is metric and it's objective, and you can measure it. You can then make decisions based on that, and it's relatively simple to judge it and to take actions like, oh, I'm going to change my scheduling method. But when it comes to agentic provenance, one thing that I feel like is still missing is we can, yes, find the origin or the source of how this came to be, but we still need to make a judgment on whether we trust it or not. And that is more of a subjective judgment as opposed to an objective one, right? How do we reconcile the two?
I think it's not about trusting afterwards. I think it's more of understanding what happened. Because if after few iterations of my workflow, I find out that what's going on is wrong, or I don't really like the results, then I have, through the provenance collection, I have the possibility to go back and track where the problem started. And then if the problem started at a given agent, for example, I could think about taking an action, and it's going to be, okay, I will implement a safeguard just after this agent to answer this problem and say that, oh, actually it is doing some math error. So let me try to figure out how I can fix that, or use a more deterministic safeguard, or even say that, oh, this range is okay, this range is not, and so on. So that's actually the way I think about it. To go a little bit further, I think the goal from having the provenance is definitely not trusting this system. So actually, I'll have the whole trace to understand what's going on, because I don't trust what they are doing. And if something is wrong, then I'll have the tools to be able to understand what went wrong.
Is that working? Oh, yeah. I guess I was looking at it from how do I trust what the agent is doing is actually correct or not, based on the training data that the agent might have been exposed to at the beginning. Totally get that you can capture the output of it and flag it as probably not correct or something that needs to be remediated after the fact. But I guess I was thinking provenance of the agent in terms of the corpus of information that it's being created with, and whether that source of information is trustworthy or not, and whether you ascribe any value to that a priori as opposed to after the fact.
I think I see your point. I think it makes sense, because that would also help understand what's going on. But the way we are at least doing it right now is like after we have the model and it has been trained, we are using it in a real workflow rather than using training data. Though in one of the slides for the multi-layer reliability framework, there is one component which is tagging data as toxic for the system, which is, for example, I am having some input query or whatever, and this data is misleading my system. And if I detect that, I can tag it as harmful to my system, and I have this storage. I mean, the way I thought about it is just like, some IPs that are, we know that these are spam, so I just block them, and I don't want to receive any data from them. So mainly, you think about it as, okay, I have this toxic data store, and I can check it from time to time to see if these data are being toxic to my system, and they are just getting the system down, or being randomly stupid.
Ben?
Yeah, I just had a question or maybe clarification, because workflows can be an overloaded term. So you had the instrument sitting there, and it's giving some data, and what you're analyzing, is it the workflow from when the data comes over and it spawns off some tasks to do some analysis or something? Does it include what the instrument is doing, or just that computational part?
It just includes the computational part.
Okay. good to hear you're working with Renan. I will throw out another name, Stephen DeWitt. He does some of the agentic AI work. So if you haven't talked to Stephen, I would highly recommend reaching out to him.
I think I know him.
Yeah, he's a great guy.
Isn't it wonderful that in the world of multicore world, two team members of U.S. national labs connect in humble autotautic, right? Anna.
Good talk. So you talk about provenance capturing, performance metrics, and all this. This is going to be a huge amount of data. And you knew what you wanted to look for here, so you know how to handle the data because you kind of know where you're going. But how do you see this going forward at large scale? Are you going to keep all this? Are you going to train models to generate the data?
That's a great question. And we had this question for a long time, which is great. I am collecting for one of the workflows, not the one I presented here, but another one. I had 170 gigabytes of performance and provenance data. And we were hoping that some people use it, but the project ended before we get there. But anyway, we still have the data. So that's to say that that's still a question of how are we going to use this data or how to demonstrate that this data is useful, actually. Not only the performance one, because the performance one, it has been useful for me to improve the performance of these workflows, but the provenance one and how we can demonstrate that actually, if we don't have this, we're going to miss out some actions that we had to care about, actually. So another answer is about the model part. And yes, we've thought about using this data to feed performance models, actually. So, but we didn't realize that yet. And if you are working on that, let's collaborate.
Excellent. Please join me saying thank you to Amal for a wonderful talk.
Thank you.